let's run through the general controls of our P51D Mustang. So as I said, there's this basically that move anything and absolutely everything control. So this can be rotated. So as I said, this also indicates the runway direction. So usually, and in this case I did, and you really should, because there's some things about rotation order that you sometimes have to keep in mind. The plane is looking along the positive z-axis. As you can see here, its up direction is y. So if I use the front camera in Maya, that also means, and Maya tells you which are the directions your asset should be oriented. If I use the front camera, you can see that's the front, that's the side. You can have your assets aligned along the x-axis, actually. And actually, that's different from application to application. So if you're working in 3ds Max, your z-axis will be up. So every other thing is going to be different there. And there's different conventions for that. But just as a general rule, positive z is usually your forward direction in a lot of tools, at least. So yeah, I can change that. The reason I have it this way is because the auto wheel rotation is locked to this direction. There are ways you can have wheels rotate with your asset anywhere it moves. That introduces some form of a runtime expression that is actually... I'm going to talk about it later when talking about the propeller, but let's just say if you have your wheels rotate with a bit of vector math freely in the world, you will have to generate keyframes from that before rendering. So you basically have to bake your animation down. You don't have to do if the direction is locked, because you can actually use just some simple math to let the wheels rotate. In this case, I decided to do so just because it's easier, and for the shots I plan to do, you can't really see actually if the wheels are rotating correctly. They are in the shots. Because the plane is running along this direction. If it would taxi off to the side on a runway, the wheel rotation would get wonky. It would work, but it wouldn't rotate the actual distance that it should if the plane is not oriented along its local runway Z here. That's a shortcut. You wouldn't do that on production. You'd probably have, if you're building a asset this way for multiple shots, you definitely have shots somewhere on an airfield where a bunch of them are taxiing, where a bunch of them are on the ramp, where a bunch of them are on a runway. So most of the time you don't notice the wheels rotating anyway on shots where you're maybe this far away, but you would have that move freely. I didn't, because it's also easier to explain to you in the end. So yeah, you can use this to move the whole plane around. You've got this general plane controller, which is basically your flight controls. So I put a lot of controls that you would usually put on the master control here on the flight control, because well, most likely your plane will be flying. So there's probably more shots of it flying in any kind of production than of it just being on the ground. So a bunch of things, because most likely you will have always selected this controller if you're manipulating the general asset. You can turn off the ground controls here, so you don't see them, which is kind of important. If you have it flying, you don't need any more stuff in the scene that you never need. This thing up here, I'd usually hide that. That's a shader control, so a bunch of things about the plane can be controlled. Shading aspects of the plane can be controlled from the rig. That's something you don't usually do on production. On smaller things, definitely. On larger things, well, shading will be done in parallel with everything else, or at least started and then be fine-tuned at a later stage. But usually things are developed in parallel. there will be a lot of different persons just responsible for the shading than for the rigging and the animation. So you kind of obstruct the freedom of the lighters and shading TDs to do whatever they want to do with the asset in the rendering stage if it's locked on the rig. In this case, and just to show some general concepts on what you can do, which is not to say shading artists might put something on the rig later if it's needed, so that's depending totally on the needs of the production, but usually you wouldn't. I did because this plane has to have some variation. There might be multiple assets, and I can control some things on that thing. I'm going to go into that when we're looking at the rendering stage. So as I said, I can move the plane about. The ground controls are going to follow. So if I have it starting, I can put it back on the ground again somewhere else. As you can see, the wheels will also deform or start to deform when touching the ground. So as long as I keep the plane oriented in this runway direction, the auto wheel rotation, which I can demonstrate here, will also gonna work flawlessly. As you can see, the wheels down here are rotating. As I said, it will not if it's landing that way. The question is whether you will notice. So on some shots you can just get away with that. So yeah, that's the main control. You can see that the plane is actually with its tail wheel. When it's on the ground, it's of course resting on its tail wheel. So that's a different control. I could have implemented it in a way that you can use the flight controls for that, but actually I want to use the flight control or this main control to control the orientation of the plane on the ground. And for that, if the tail wheel moves, the plane will not move in. If it was that way, the plane will not move along that axis. It will move along the world Y, or whichever is your up direction on the ground. So I kept it that way, and there's a different controller which is basically right in the middle of your wheels. It's not exactly in the middle, because the wheels do have some individual ground push and shock absorber movement, but it's generally at the wheel hub location in 2 dimensions. So this is the ground rotation control, and I can use that when the plane has just touched down or when it's starting. I can use that to have it elevate from the ground or get back to the ground, which gives me also 2 levels of control. So I can animate this control, and I can also animate its rotation along this axis, which gives me the ability to do some nuances that the plane does when it's taking off from the ground or landing, which I couldn't if this was just one control. So I decided to basically split this into 2 individual controls. If we move back here, and I'm just going to rotate X here, which is the axis that this is going to rotate about, you can see that as soon as the wheel touches the ground, it will going to get deformed and kind of like rest on the ground. So yeah, for the in-flight position, you would put it here, and then the actual main controller behaves the way that it should. As you can see, you can now animate the plane flying. Let's return back to the ground rotation for a moment here. So if the plane is currently somewhere on the tarmac, this ground controller has a bunch of different options. So there's this little 2 triangles, and as I said, there's some noise involved here and there. So I'm actually this ground push and the ground itself and the plane itself, they do have a predefined noise animations that I can tune in to kind of like have it move a little bit randomly on the ground, because usually the airfield will not be completely flat and you have some little jumps here and there. So that's implemented here. These little triangles are a control indicator object. So basically they are there so I can take a look at how the ground is being influenced by the noise. So if I turn off hide on playback here for a moment, I don't know why that human AK window always likes to pop up. You can see nothing is happening right at the moment. So that means the ground does not use its noise animation at the moment. If I go in here and I'm just going to push the ground noise scale to 1, you will see that the actual controller stays the same because it's responsible for deforming the wheels, but you can see that there's a little bit of indication on how the ground is pushing against the plane, and you can see that the whole plane is actually rattling a little bit. So it's wobbly, especially on the tail wheel. You can see that it's sometimes kind of like moving off the ground. So this is kind of like pushed to the extreme. This may be a bit much, but if you're in a distance shot, you definitely want to maybe push it to some extreme value to actually see some little bit of natural wobbling. The thing why I have these indicators here, and the thing I did, this shot cam is parented to that. So kind of like by using the ground noise, I can actually give my camera some energy in parenting it to it, because there will be some subtle rattling on the camera, which I found looks pretty nice. You don't have to do that, of course, and it's not part of a standard rig, but it just came in handy and it was a lot of work. So yeah, that's that. So this is just an indicator. You can't move that. You shouldn't move that. So here's the ground push. And the ground push, as I said, can be used to define how much pressure there is in your tires. So basically, naturally, it will be somewhere between those two extremes. So probably a realistic tire pressure would be something like that. So they will be pushed in by the ground because the plane is heavy. But yeah, you can control that. And you can also see when I move the plane up and down, it will come to a rest on that position. So before I start animating, so if I have a shot where the plane is landing, I would probably work on the shot in reverse and define its point of touchdown as the very first thing, and then animate to the front and to the back of that point. So I can decide on that before starting to animate, but you can always change that later. So as you can see, the ground push can be controlled. If you're pushing a ground push up, I could have done that differently, but there's really no reason to. You might have to nudge your whole thing a little bit down to actually rest on the real ground. In this extreme position, it actually does rest on the ground. So I have this little nth group down here, which I can unhide. So that's just a little ground. Normally you wouldn't have that in your scene, but you also wouldn't have any lights, which is the LGT group up here, in your actual master scene, because you're going to import the asset and you don't want to import a bunch of lights that are not part of the asset, or some ground which you don't need into your shot file. But of course, to make things easier here and to demonstrate things a little bit easier, it absolutely makes sense to have some ground and some lights. So that's there. It's the nth group for environment, obviously. So as you can see, in this extreme position, the airplane should actually rest on the ground. So I can I can just take that thing, push it down here to have it. It's actually locked, so if I can't push the plane below the ground right now, so that's limited, which is kind of important because you can't do anything wrong. And the ground is pretty limiting for a plane in the real world as well, I'd say. So yeah, that's that. So yeah, as you can see, they are protruding through the ground a little bit, and that's how things should be. You'd never want to risk there being a gap between the wheels and the ground, because you see that the contact chatter is not actually touching. And you probably will have to re-render a whole expensive sequence if that's the case, or you put some rotoscoper up to fix that. But yeah, generally it makes sense to try to avoid that, and it happens really fast. So there's been a bunch of shots where I had to triple check the ground contact, because you just screw things up. So it happens very fast. You just push it up just a little bit while animating, and you're off the ground. So yeah, as a precaution, you can just hammer that thing down to the ground and it will definitely rest on the ground. So you can't do anything wrong here, basically, other than lifting it up again. So yeah, the way that's implemented is with a little lattice deformer. So maybe you know lattice deformers as FFDs or freeform deformers. There's a lot of names really for them. In the end, it's just a bunch of points that you can move around, like in a grid, to deform a mesh. So actually, I can show them. So the ground deformers are part of the rig. You normally have them separately, and again, like parent constrained to the controls. In this case, I just parented them because, well, this is the whole rig. There's a few things that I had to keep in absolute world space, which are also responsible for deformation. They're kind of like put in this invisible rig group, which is basically just a helper group, which you never need to care about while animating, which is just holding some things that I did not want to parent into this hierarchy here, but it doesn't matter really. So these are the ground deformers, and if I unhide them, you can actually take a look at them. And as you can see, that's just a grid of points, which has been deformed up from the original neutral position. And it is controlled by the ground push. So the actual deformer points do not change, but what is animating here along with the ground push, moving up or down, basically the weight or the intensity that this deformer gets applied to the wheel. The same with the tail wheel. So there, and as you can see, the whole plane is actually being pushed upwards a little bit if the ground push is extreme. So you could actually use that for animation. So you could animate that wobbling a little bit if you need some more movement there. If you're, for example, pretty close when this plane is landing in a shot that looks something like this. So it's pretty. Yeah, so that's pretty handy if you really need to do that. So that's that. I'm just gonna hide those deformers again. Deformers are pretty self-explanatory, so I guess you will figure them out on your own. So staying on the ground for a moment here. There's this thing, which is actually not a ground control, but since we're here, there's this little door that's part of the radiator assembly, which can vary in position. So you can actually take that and use this controller to rotate this up. You can see there's this little cylinder here that is basically well, in the plane there's this some kind of actuator that is moving that up or down. So in this case, this moves along with it, so you can close it. Usually on takeoff, that will be fully extended, as far as I know, or at least as far as I've seen in references. Not an expert on the plane, but you learn a few things while searching for references when dealing with such a thing. So there's this little tail wheel rotation control. So as you can see, the tail wheel can be rotated and moves about. So let me just quickly push that plane fully back onto the ground here. So just notice that my ground is a little bit off. So it could be that we move this, yes. We move the master controller up a little bit. So that's what happens when you don't pay attention to zeroing out your values. So yeah, that's that. So this ground push control still works. So if I rotate the wheel, you can see that it stays deformed no matter how much I rotate it. So you can actually, I didn't limit its degree of freedom. It probably would never rotate 360 degrees. But yeah, that's that. So that's it for the general ground controls. So one thing that would be would not be extended on takeoff are the flaps. So they can be selected and moved. So take the flap control. I didn't implement the fact that they are moving in parallel, so you have to select both and move both up. Normally you would. So back here on this elevator, you can see that they are moving in parallel because that's what an elevator does. But yeah, doesn't really matter that much in this case. You can select both of them and just either rotate them in the viewport or just use the channel box control to retract or extend the flaps. So usually on takeoff, that's gonna be fully up. So last thing that is probably part of the ground controls is this Canopy controller, so I can open and close the cockpit. I didn't implement that you can move it. Actually, I could have done that. For some reason, I decided I just want a slider up here, so it's a value that goes from 0 to 100, and I can just use the viewport drag slider here with the middle mouse button, and should probably turn that up. So yeah, that's that. So with this virtual viewport slider, you can open and close the canopy, and there's actually a few things in there that are moving when you're moving it back. So there's this little slat that it's riding on. It's actually rotating a little bit to the back because it has to stay on the fuselage. At least that's kind of like what I extrapolated from references, how that thing actually moves. It's not that easy to find references on the actual mechanism that move that canopy, but based on stills and some video footage, that should be close enough to how it works in reality. So, of course, after that's closed, plane is going to take up, so I'm just going to move it into its takeoff position here. And the next controls that we have are the wheel controls. So I'm going to start at the tail wheel here. So they are orange and they look quite similar, so that's some visual cue that they are kind of like similar controls that do similar things. And actually, let me just close that hierarchy down because it just looks messy right now, just to show that you don't need to see any of this while working with the plane, because everything you can do with the plane you can do in the viewport, so you never have to really look at that hierarchy, which is pretty good, because you don't get lost in some complex hierarchy and you can just work naturally, which is the whole point of using controllers. So this basically just has one slider value, so that's an extra attribute. If you use the attribute editor instead of the channel box, you have this little slider here, so you can just retract and extend the tail wheel, and if it's retracting, you can see that it will actually pull the gear well doors with it while moving up, and yeah, the whole gear spindle is going to move up. And so that's basically animated via something called driven keys, which we'll take a look at later. But basically the way I did it is I did some animation for that, and then instead of hooking it up to the time input, I hooked it up to this value. So I could basically control a complex mechanism with some more than one movable part just using one slider. So let's retract that. Plane is going to take off. And now on to the main wheel controls. So there's a bunch of sliders here. One thing I'd like to say is there are two controls, because a lot of times those wheels will not extend and retract at the same time. So you can see that when I'm just moving the gear in here, resting on the ground, it will actually also transform or deform the wheel weirdly. That's because the wheel will not be retracted on the ground. So if for some reason you need to do that, you can just move the ground push controller down while moving the gear up. But the plane will pretty much break if it's retracting its gear on the ground. But anyway, this is the gear retraction is basically meant for when the plane is off the ground, so it's not being influenced by the ground push anymore. So these attributes, gear extend, center door open, absorber extension, they are named pretty much exactly the same on both objects. So I can control them independently, but I can also control them at the same time. So if I do want to extend or retract the gear in parallel, I can just easily do that. And usually I'd start by animating them in parallel, and then maybe introduce some offsets to gives it a slightly natural time-based offset where the wheels do not really retract exactly at the same time, although they sometimes do. So that's different from case to case, I guess. At least that's again what the reference tells me. So yeah, you have this gear extend, which is gonna pull in the whole gear into the gear well, and at a certain point it will also start to retract this little landing light right here. So the actual gear well door on the wing is pushing against that light, and that's gonna make it move inward and be stowed in the gear well. So the other thing is, of course, these center doors, which can be extended or retracted. And if the gear is extended, there's also a little thing that can be animated, and that is this absorber extension. So when a plane is on the ground, the ground is usually not flat. So by animating this, you can introduce either a bit of wobble, and you can also, when the plane just has taken off, you can extend them, because they will extend to their almost full length, I believe, after takeoff, and they will retract a little bit before being stowed in the gear well. At least that's what I extrapolated, so I'm not really sure about that, but well, you never really will see that. The only thing is, if they're completely extended, I couldn't find a way to actually stow the gear in the gear well. So if they are fully extended, they will actually interpenetrate with these doors here. So the absorber extension can not be 100%. So I'm pretty sure my my measurements are slightly off. So I had to work with blueprints from the internet and studied a lot of references. So that might be different on the real plane. I really don't know, but it definitely works for a VFX shot. So let's put the gears in. And gone they are. Plane is flying. Next thing are the flight controls. So let me just skim over them. That's pretty easy. So these are the aileron controls. The aileron is responsible for the roll of the plane. So usually they work in a way that the one aileron moves up, the other moves down. So the plane starts to roll to the left or to the right side. These ailerons have little trim tabs on them, so they do a little bit of counter rotation. So I've hooked both of them up to the same controller, so whenever I move that or rotate that controller up, the little trim tab here is going to move in the direction opposite of that. They are used to prevent the actual control surface here from fluttering in flight, so that you have more precise and easy control on the plane, I believe. So the same thing is true for the elevator. So if the elevator moves down, the trim tab actually moves up. Maybe, although I wanted to do that later, because it's a pretty easy setup. So let's take a look at the aileron tab or the elevator tab. They're pretty much the same. So as you can see, I didn't name my float math here, but I really don't care right now. So easy control, the rotate X value of that controller. And let me just quickly dock that here for a moment. So the rotate X value of the controller, I'm just gonna through that quickly because it corresponds to the thing I was showing earlier. Basically, it's a simple control. The elevator control will actually here it is. So the elevator control is, here's a little helper control which is hidden between them for the left and right side. Doesn't matter really much. So this elevator control, if it's moved up and or down, the rotate X value is basically gonna get pushed through to the elevator rotate X. So nothing complicated here. It's a direct connection. They are buffered, so that can be done. And here's this little trim tab thingy. And as you can see, this float math just takes the rotate X value of the actual elevator and it multiplies it by -1. So in the end, if it's currently a rotation of -25, the trim tab rotation will be +25 and vice versa. So basically it's just counter rotating. I'm not sure if they're really counter rotating fully, or if maybe if the elevator is moved 25 degree or something like that, or 10 degree, that the trim tab just moves a fraction of that. Wasn't really actually apparent in the footage, so I just decided that would be the easiest way to set this up, and it pretty much looks like the reference. So yeah, that's hopefully somebody correct me here who knows that plane way better than I do, but yeah, it's close enough, I guess. I hope. Same with the rudder. There's a little difference. So if I take a look at the rubber, that's just using the same rotation, because the rudder on the P51 is different in the way that the trim tab on the rudder is actually basically adding its rotation to the actual rudder rotation. So it basically moves in the same direction a little bit more than the rudder actually does. So let me just undock that here again. So yeah, that's that. They will move as they should. So all you have to care about are those few controls, and you don't have to animate the little trim tabs as well, because that's an automated process in the real world. So an animator shouldn't have to go in there and whenever they move the aileron up, move the trim tab down, because it's just tedious work and it's boring, and yeah, it's not really something you should hand animate on every shot. So let's move on to some of the very last controls and then take a look at the actual node editor setup. The next thing we could take a look at, let me just hide that ground here because we're now flying. The next thing we might take a look at are those little wiggly lines around here, or maybe something like a sine wave. This is the controller for the wing bend and wing flutter. So I cannot actually move that controller, and it has controls for all of the wings on the same shape. So there's a few attributes here that you can control. So that's the wings flutter scale, flutter frequency, wing bend left, wing bend right, stabilizer flutter scale, and flutter noise left to right offset. If I push the flutter scale to its maximum, which is 3, and just have it run through the timeline, you can see that all of the control surfaces are or better said, that the main wings are fluttering up and down. So now value of 3 is pretty high. So you would usually keep that maybe between 0 and 1, but I kind of wanted to allow pushing it to the extreme, because in the end you might want to make things a little more obvious than they would be in reality. So anyway, you could just maybe animate it up to 3 when the engine actually starts. So in the animated file you saw that the wings were actually doing a pretty harsh transition to moving up and down when the engine started, because after all, if that Merlin starts up, there's little explosions going on. The plane is pretty much rattled through and through. So this shaking actually turns down after a while. So maybe on the runway, those wings will maybe just flutter a little bit. But yeah, the left to right offset actually controls whether both wings will flutter at the same time, or if the noises that are controlling those wing movements are actually offset in time to just kind of like vary it a little bit. So as I said, 3 is a bit much, so maybe if you put it down to 1, that's even still a lot, so maybe 0.4 or something like that. That's probably what they do in reality. So you can control the flutter frequency. Let me just put that back to 2 here maybe. So if I turn that down, the flutter will be slower. So it just looks kind of like a cartoon plane, which is kind of like wobbling with its arm. But if you keep that on a high frequency with motion blur, it will actually look like the plane is shaking. So if I turn that back down, there's also the stabilizer flutter scale. So whoop. If we go back to that flutter frequency, it's actually the same frequency for all of them. You will see that the stabilizers are also fluttering. So when the engine starts, they will get a pretty big push and flutter. But in flight, you would usually never see that. So as soon as the plane has left the ground, you would pull up, probably just animate those wings flutter scale and stabilizer flutter scale down to 0 or a very, very low value. But the other thing that you can do with that control, you can just control the wing band on the right and on the left side. So if the plane is doing a steep dive and recovering and pulling up, and the G-forces are acting on it, the wings will get pushed up or down, depending on the direction of flight. If the plane comes out of that dive or climb really, so you can do that with the wing band. So this is not animated. This is just a static deformation. So you can add some of that in. Again, it's a subtle effect. You shouldn't push it to the extreme. It certainly can be pushed to the extreme, but maybe it will just move in this range. So again, the way this is implemented is by using deformers. So if I expand the hierarchy here again, there's deformers wing band, and there's 2 bend deformers for the main wings. So they're just bend deformers, which will linearly bend the surface that they are bound to. So the surfaces of the wing that are controlled by this bend deformer are basically these without the gear assembly, because if I had deformed, then I would have had to deform a lot of small objects, and it would have made things pretty much unperformant. So since you can really only notice the wing band mostly on the tip of a wing, and it will bend maybe from this point on, it now bends from this point on, that was close enough without kind of like messing up a lot of surfaces here. So there's just a few polygons to deform. It's fast, it's easy, and as you can see, if I go back to this control here, it pretty much deforms the majority of the wing. So that works. So the bend deformers are responsible for the main wings and for the tail surfaces, because for various reasons a bend was impractical there. I used Lattice deformers again, and I selected the points on the outer edge of the deformer, and I clustered them. So I basically created a little control object for them, so I could push the points of the deformer up or down, and then I basically just hooked that up to a noise, and we will take a look at this later in the node graph. So basically it's just hooked up to the noise, so it's moving up or down over time, controlled by this flutter frequency. So obviously the last thing here is the actual propeller, because currently that plane falls out of the sky like a brick because it's not rotating, but of course you can animate that one. So the propeller on the P-51 from the pilot's perspective is rotating clockwise, so you would put in only positive values right here. And when a plane is on the ground, that prop would most likely be at a 45 degree rotation. So I kept it where it was because I modeled and set it up that way. But as a plane parked on the ground, you would probably put it somewhere around 45 degree. But that varies, so you don't have to, but it's kind of like most of the pictures of parked P-51 show them at roughly a 45 degree angle. So of course you could just come in here and then maybe just go to your first key and then go to, let's say, frame 40 and put in a rotation of 360 degree, and that's going to be a pretty slow rotating propeller, but you can always make it faster. And usually if the engine is not starting and the plane is just keeping a constant RPM of the motor, you would of course just go in here. You wouldn't animate any of these things here, so you would just animate the rotate Z value. You keep it linear, and of course for the whole duration of your shot you would just cycle the post and pre-infinity, and it's gonna be a constant curve. And then to get the right amount of motion blur, you would just put that to the speed that you need to get the correct kind of look. So in flight, that prop on a usual film camera, 24 frames per second, and a 180 degree shutter, that thing would usually just be a circle. You would see some movement in the highlight that the props are catching, but if you're using motion blur with enough time steps in a renderer, the prop will look correct. You usually wouldn't have it be rotating as fast as it would be in reality, because that would require, well, probably 100, 200, 300 time steps per frame to evaluate to get the rotation. You wouldn't do that. You usually keep them slower in CG, but of course that would require you to the initial rotation. So if you want to animate this prop starting, you'd have to kind of do some tricks to get that right. You wouldn't really work with the real world rotations. But there's another way to animate this propeller. So you obviously can just use this, especially for shots where you maybe just want to slowly turn it until it just starts to move, and you're cutting out of the shot right then. You would do that. When animating a plane or such a kind of technical object, you usually also want some control that gives you kind of like a natural control over the plane. So the propeller also has this option here, which by default should be 0, so that's use RPM. So you can actually put in some rotations per minute value to control the propeller, which means that you can also ramp up or down this value over time, and it will start to spin up or slow down. So if I put the RPM, use RPM here, and if I use a little small value, so like something like 5, you can see that the rotator will start to spin over the animation. So one thing you will notice is that I've moved back in the timeline, or anywhere really the whole time it is moving, because that's a runtime expression, and it will react to pretty much anything you do in the interface of Maya. So this one will always be spinning. It's reset on frame 0, and you could reset that on basically any frame really. But yeah, that's just how it behaves, and there's a few pitfalls with using this method, which I'll show in a few moments. But it's a natural way to animate a propeller. So maybe you're 100 frames, so, or maybe you start at a frame 100. So we kind of like use a little pre-run here, and your propeller is at 0, so it's standing still, and maybe 40 frames in the engine starts. So this ramps up to, let's say, slowly to 100 rotations per minute, so, or maybe even slower, so like that. So it's gonna go slowly and vroom vroom vroom, it's gonna start now. So that's actually already pretty fast. So the real thing will spin up to maybe a value of 2,700 RPM, or I think it goes as high as 3,100 or 3,300, which I believe is kind of like the maximum of the Merlin engine. Now, anyway, you would put that in because that's the actual real world values. So you can basically just take a look at the specifications of the plane and basically just do it like it would be in real time. So you see that the prop, of course, in the viewport, it just looks ridiculous spinning left and right, but that's what propellers do if you don't have any motion blur. And on cameras with a different shutter speed or with a rolling shutter, and not an actual film camera with a 180-degree shutter, you can see some pretty crazy effects that propellers produce when captured on film, or when I said a digital sensor. And you can produce these artifacts in CG as well. You can generate a rolling shutter effect, for example, in Arnold, to kind of like account for that if you have to get such a plane into digital footage. But usually propellers just look really bad on any kind of modern non-global shutter camera. So really props just look good on 24 frames per second 180-degree footage. But you can do that. So there's this one other thing. So it's the motion blur scaling factor. And the motion blur scaling factor is basically responsible for slowing the propeller down again for rendering. So the actual rotation speed is kind of like divided by that value, so it's not really a factor, although I called it that. It's more like division. But in the end, you can use that value to control your motion blur. So as I said, 2,700 rounds per minute, you really can't render that. So it just uses a ridiculous amount of steps in between that have to be evaluated. So you kind of like have to find a balance and maybe do a few test renderings with different values at the beginning to kind of like decide what works for that kind of production. So, but that's something very specific for propellers. And let me just quickly show that in a different file. How that's set up and why this might be a problem with rendering, because that usually it actually pretty much is a problem whenever you're using runtime expressions. So that's also the reason why I implemented the wheels differently, because I have the same problem. And let me just show you in a different file. So it's time for the second Maya instance again. It's already there, so just do that. Hello. Thank you.